Porting a cylinder head using carbide burr tools is a precise process that involves reshaping and smoothing the intake and exhaust ports to improve airflow, which can enhance engine performance. Below are detailed, step-by-step instructions for cylinder head porting using carbide burr tools. This assumes you have some mechanical experience and access to a well-equipped workspace. Safety and precision are critical, as mistakes can damage the cylinder head or reduce performance. Step-by-step instructions for cylinder head. Porting with carbide burr tools. Preparation. Gather tools and materials. Carbide burr tools. Use a variety of shapes: cylindrical, ball, oval, flame, and sizes, 1/8 to 1/2 of shank, for different areas of the port. Double-cut burrs are ideal for aluminum heads, while single-cut burrs work for cast iron. Die grinder. A high-speed air or electric die grinder, 20,000–30,000 RPM, with a variable speed control. Safety gear. Safety glasses, dust mask or respirator, ear protection, and gloves. Measuring tools. Calipers, machinist's ruler, and flow bench, optional but ideal for testing. Cleaning supplies, brake cleaner, shop rags, and compressed air. Marking tools. Permanent marker or machinist's die, e.g. dicom, to mark areas for material removal. Sanding rolls cartridges, 80 to 120 grit for smoothing after burr work, plus finer grits, 200–400 for polishing. Workspace, a clean, well-lit area with a vise or headstand to secure the cylinder head. Reference materials, factory service manual or porting templates for your specific cylinder head, if available. Understand the cylinder head. Study the cylinder head's design, including port shapes, valve sizes, and flow characteristics. Research the engine's intended use, e.g. street, race, or forced induction, to guide your porting strategy. Identify key areas: intake ports, exhaust ports, valve seats, valve guides, and combustion chambers. Note: different engines require different porting approaches. For example, high RPM race engines prioritize velocity, while street engines may focus on low-end torque. Disassemble the cylinder head. Remove valves, springs, retainers, and other components using a valve spring compressor. Inspect the head for cracks, warpage, or damage. If damaged, consult a machine shop before proceeding. Clean the head thoroughly with brake cleaner and a wire brush to remove carbon, oil, and debris. Secure the cylinder head. Mount the cylinder head in a vise or headstand, ensuring it's stable and accessible from multiple angles. Position the head to allow easy access to the ports you'll be working on, intake or exhaust. Plan your porting strategy. Mark areas for material removal with a permanent marker or machinist's die. Focus on intake ports. Enlarge and smooth for better airflow, maintaining velocity. Exhaust ports. Optimize for scavenging, often requiring less material removal than intake. Valve bowls. Blend transitions near the valve seats. Short side radius. Smooth this critical area to reduce turbulence. Combustion chambers. Polish to reduce carbon buildup, optional. Avoid removing material from the valve seats or guides unless you have professional machining capabilities. If possible, use a flow bench to establish a baseline flow rate before porting. Porting process. Select the right carbide burr. Cylindrical burrs. For straight sections of the port or gasket matching. Ball or oval burrs. For smoothing curves, valve bowls, and short side radius. Flame or tapered burrs. For detailed work in tight areas or transitions. Use smaller burrs for precision and larger ones for bulk material removal. Set up the die grinder. Attach the chosen carbide burr securely to the die grinder. Adjust the grinder to a moderate speed, 10,000 to 15,000 RPM for aluminum, lower for cast iron, to maintain control and prevent overheating. Ensure the air supply, for pneumatic grinders, or battery, for electric, is sufficient for uninterrupted work. Begin porting. Material removal. Start with intake ports. Gasket matching. Align the intake manifold gasket to the port entrance and mark areas where the port is smaller than the gasket. Use a cylindrical burr to remove material, creating a smooth transition to match the gasket size. Port runner. Widen and smooth the runner, focusing on removing casting imperfections, e.g., flash or ridges. Maintain a consistent shape to avoid disrupting airflow. Valve bowl. Area. Use a ball or oval burr to blend the area just below the valve seat. Smooth the transition from the port to the valve seat to reduce turbulence. Short side radius. Carefully smooth this tight curve with a small oval or flame burr to improve flow without removing too much material. Exhaust ports. Focus on smoothing rather than enlarging, as exhaust flow relies on velocity and scavenging. Remove casting imperfections and blend the valve bowl area. Avoid over-enlarging, as this can reduce exhaust velocity and hurt performance. Technique tips. Work in small, controlled passes, removing no more than 0.01 to 0.020 inches of material at a time. Keep the burr moving to avoid creating flat spots or gouges. Periodically check progress with a light source, e.g. flashlight, to inspect port shape and surface finish. Use calipers to ensure uniform material removal, and avoid thinning walls excessively. Smooth and blend. After rough shaping with carbide burrs, switch to sanding rolls or cartridges, 80-120 grit, to smooth the port surfaces. Focus on eliminating burr marks, sharp edges, and uneven areas. Blend transitions between the port runner, valve bowl, and short side radius for a seamless flow path. For high-performance applications, polish the ports with finer grits, 200-400, to reduce boundary layer drag. Note: over-polishing exhaust ports can reduce scavenging efficiency, so keep them slightly rougher, 120-200 grit. Check valve guide. Clearance. Ensure the valve guides don't protrude excessively into the port, as this can disrupt airflow. If guides need trimming, consult a machine shop, as this requires precision to avoid damaging the guide or seat. Clean the cylinder head. Use compressed air and brake cleaner to remove metal shavings, dust and debris from the ports and combustion chambers. Inspect for any missed rough spots or debris. Test and verify. If you have access to a flow bench, measure the airflow through the ports to compare with your baseline. Look for improvements in cubic feet per minute, CFM, at various valve lifts. If no flow bench is available, visually inspect the ports for smoothness and consistency. Check gasket fitment to ensure proper alignment with the intake manifold and exhaust headers. Final steps. Reassemble the cylinder head. Reinstall valves, springs, retainers, and other components using the valve spring compressor. Check valve-to-seat contact and ensure proper sealing. If seats were affected, have them professionally recut. Verify valve clearances and spring pressures per the manufacturer's specifications. Inspect and double-check. Ensure all ports are symmetrical and consistent across all cylinders. Confirm no thin spots or cracks were created during porting. Use a dye penetrant test if needed. Verify that the head is clean and free of debris before installation. Install and test. Reinstall the cylinder head on the engine, following torque specifications and gasket installation procedures. After installation, run the engine and check for leaks, unusual noises, or performance issues. If possible, dyno test the engine to quantify performance gains from porting. Safety and best practices. Safety first. Always wear safety glasses, a dust mask, and ear protection. Metal shavings and dust can cause serious injury. Work slowly. Remove material gradually to avoid mistakes. You can't add material back once it's removed. Know your limits. If you're unsure about valve seat work or structural integrity, consult a professional machinist. Maintain port velocity. Avoid making ports too large, as this can reduce airflow velocity and hurt low-end torque. Document progress. Take photos or measurements at each stage to track changes and ensure consistency across ports. Engine-specific research. Porting strategies vary by engine, e.g., 2-stroke versus 4-stroke, small block versus big block. Consult forums, books, or experts for your specific application. Common mistakes to avoid over-porting. Removing too much material can ruin port velocity and reduce performance. Uneven ports. Inconsistent port shapes across cylinders can cause uneven power delivery. Damaging valve seats or guides. Avoid grinding near these areas unless equipped for precision machining. Ignoring flow testing. Without a flow bench, you're guessing at performance gains. Visual inspection alone isn't enough. Poor cleaning. Leftover debris can damage the engine upon startup. Additional notes. Skill level. Cylinder head porting is an advanced skill. Practice on a junk head first to build confidence. Time estimate. Porting a single cylinder head can take 10-20 hours for a beginner. depending on complexity and tools. Cost: Carbide burs, $10 to $50 each. Die grinder, $50,200. And sanding rolls, $20 $50, are the primary expenses. A flow bench, if used, is a significant investment, 2,000 BOAS. Resources: books like How to Port and Flow Test Cylinder Heads by David Vizard, or online forums, e.g., Speed Talk, Yellow Bullet, offer valuable insights.